Hello everyone and welcome back to MV Tutors. My name is Tilo and I'll be looking at the logarithmic rules. So we know that in matric you'll be using logs, especially when you're dealing with the inverse functions of the exponential graph, right? And also when you are solving, this is now talking about financial maths, when you're dealing with an annuity and probably even a compound interest formula problem, right? So when you have the exponent as the unknown and you need to solve, you will be using logs. All right, so let's just go through some rules. I'm going to go through 8 rules. You're probably not going to use all of them, but it's good to know them, right? Let's just make sure we cover everything that we can and understand logs better. So before we even begin, it is good to note, throughout I'll be using M, N, and B, right? So how do you pronounce it? You say log M base B is equal to N, all right? Now the rules are B, your base, must be bigger than 0, okay? And it cannot be equal to 1, all right? And both M and N are also in a position where they have to be bigger than 0 and that they are real numbers, okay? So basically now, just looking at this, if I have, like I said, n is my unknown, so m is equal to b to the power n. If n is my unknown, how do I solve it? So basically, I would say log base b, right? Log m base b is equal to n. That's how I would write it, okay? So n would be equal to log m base b, okay? That's how you say it in that order, although we write log bm. It's actually log m base b. Now let's go to the first rule. All right, and you can see with this dot over here, which means product, okay? So basically this is the product rule. And this rule, what does it tell us? So it says that the logarithm of the product is the sum of the logarithm of the factors. What does it mean? So I have log m times n base b. Okay, so we're saying the product, then the logarithm of a product is the sum of the logarithms of the factors. So basically it would be log m base b plus, okay, so this product, we're going to deal with the sum. So log m base b plus log n base b. Okay, and that's how you do it. And now how do we deal with this example? Well, this example, I have the same base, right? It's important that the bases are the same in this case. So I can write it then as log 2 times 12, because remember here, this is the sum of the logarithms. And then what do? I would multiply, okay, as this is the product rule. So 2 times 12 and then base 6. So 2 times 12 is 24. So I have log 24 base 6. Okay, and you can see there on the calculator, if I were to say log 2 base 6 plus log 12 base 6, that would give me 1,774. And then if I have log 24 base 6, again we get 1,774. So it works. Now we go to the second rule, which is the quotient rule. All right, so here quotient, we are basically dividing. Had to think for a moment there. How do you spell quotient again? There we go. So now we have log m divided by n base b. So what happens then when you have when you're dealing with rule 2, which is the quotient rule? Basically, the logarithm of the ratio of two quantities is the logarithm of the numerator minus the logarithm of the denominator. It's important, numerator minus denominator. So we have log m base b minus log n. I probably shouldn't have chosen n and m because they sound the same. Okay, so there we go. All right, like we said with the quotient rule, we have the numerator, the logarithm of the numerator minus the logarithm of the denominator. So with an example over there, okay, so again I have log 12 base 6 minus log 4 base 6. So I can rewrite it as log with the base of 6, and then the 12, because we start with the numerator and then denominator. Okay, so basically I have log 3 base 6. Okay, and you can check again on the calculator. You'll see that it actually works out quite well. All right, the answers will be the same. Now, going on to rule number 3. Okay, I see we have an exponent there. We have a power there. So rule number 3 will refer to the power rule. Okay, and now what do we do whenever you have an exponent? With a power rule, you're going to take it all the way down. This is a nice rule. I love it. As soon as I see exponents, powers there, I know I'm going to take it down. The log will help me take that exponent to the ground. Okay, so basically the logarithm of an exponential number is the exponent multiplied by the logarithm of that base. So the exponent multiplied by the logarithm of that base. Okay, so that's how we deal with exponents. So here, if I have log 81 base 3, I can rewrite it as log 81 is like 9 squared, right? Okay, and then I can take this squared to the front. So 2 log 9 base 3. Okay, or you could have said 81 is basically 3 to the power 4. And now we're taking that 4 to the bottom, bringing it down. So 4 log 3 base 3. Okay, and we're going to talk about this soon, but I'm going to just say now the answer is 4. We'll get there. Okay, now rule number 4. Okay, rule number 4 is basically called the zero rule, and you'll find out why I'm saying it's the zero rule. So basically, the logarithm of 1, yeah, so you have a logarithm, because this is log 1 base b, right? So the logarithm of 1 to any base, that will be equal to 0. Okay, the logarithm of 1 to any base is equal to 0. And that is provided. Remember that what I told you about b? B has to be bigger than 0, and b cannot be equal to 1. Alright, so this is where this is applicable. Let's just test that out. Are you sure that the logarithm of 1 to any base, so if I chose 78 as my base, I get 0. If I chose 5 as my base, I get 0. So the logarithm of 1 to any base is always 0. Hence, it's called the zero rule. Okay, and then we're looking at this example. So over here, actually, let me just go back. So if I were to take this, just to demonstrate why I'm saying what I'm saying. Okay, let's just paste it over there. So if I were to have log 1 base 10, okay, just think about the b being 10 and the m being 1. That is the same, if I were to look at it in this way, that is the same as saying I have my base 10, right? So that's 10, okay, and then the 1 there, which is my m, that's the 1 there as well. So what then, if x was my unknown, what would 10 to the power of what? Oh gosh, the English. So 10 to the power of what will make it equal to 1, and that's 10 to the power 0. Okay, so yeah, so basically with the zero rule, this is what it is, and how we rewrite it, we're going to say 10 to the power 0 is basically equal to 1. That's the zero rule. Now rule 5, this is basically referred to as the identity rule. Aha, you remember when I said we'll get back to it? Remember this? Then we are there now. So basically, I have log of a number which is equal to its base. All right, so log b base b is basically equal to 1. All right, so again, the logarithm of this number, by the way, inside the brackets is called an argument. English. So basically, the logarithm of an argument, wherein this argument is equal to the base, is going to be equal to 1. All right? Remember, this base has to be bigger than 0, right? Okay, hope you got it. The log of an argument, where the argument is equal to the base, will be equal to 1. Always. All right? So log 5, base 5 is equal to, what did I do now? It's equal to 1. And why is that? If you go back to this, so you have a base of 5, okay? And you know that the answer there has to be 5, so what would that be? That would be 1. 5 to the power 1 is 5, hence I wrote that. All right, and then moving over to rule number 6. So now we have log b to the power k, base b, okay? Looking at this, because I have an exponent, I'm excited. I would just put the k down, and I have log b base b, and what I've learned previously with the identity rule, I know that that's equal to k. But what is this rule called? So basically, this is the inverse property of a logarithm. Okay? Inverse property of a logarithm. Okay? So basically, with this inverse property, the logarithm of an exponential number. So this is an exponential number. The logarithm of an exponential number where its base, okay, no, let's start like this. So the logarithm of an exponential number where its base, okay, there it's its base, is equal to the base of the logarithm, would say that at the end that logarithm will be equal to the exponent. Okay, let me say that again. The logarithm of an exponential number where its base is the same as the base of the log is basically going to be equal to the exponent. So without even going through this step, if the base here is the same as the base of the exponent, then I know whatever that exponent is, that is the answer. Okay, so even here, log 7 squared base 7, the base is the same, so my answer will be simply 2. We're almost there, guys. 2 more rules. So rule number 7. Okay. Now we have the log scenario here as an exponent. What do we do with that? So this rule will be referred to as the inverse property of an exponent. Okay, that's the inverse property of the exponent. So what does that rule say? So basically it says raising, so because we've raised the logarithm of a number, right? So raising the logarithm of a number to its base. Remember, we have a base here. So if you raise this entire logarithm to its base, because the base is there, base b, we have that base. Okay, raising the logarithm of a number to its base is equal to the number. Okay, we have log k. Okay, raising the logarithm of a number, which is k, to its base is equal to the number. So we know that as long as the base here is our base here as well, then we know that our answer there would be k. Okay, so basically the bases here are the same, similar to rule number 6. All right, so I know that my answer then would be 5 for this question. Okay, that is rule number 7. All right, raising again, let's just repeat it. Raising the logarithm of a number, which is that k, in this case, which is 5, the logarithm of 5, log 5 base 3. So raising the logarithm of a number to its base is equal to that number. And then rule number 8. So if I have log m base b, another way I can rewrite this actually helps a lot. This is quite important. All right, another way of writing it is writing it that way. Okay, so you have your base here. It means that's the denominator. The number there, which is m. So log m base b. That will be on your numerator. B will be at your denominator. And that's basically that with the rules. Okay, now let's look at some examples where we are solving for x. How are we going to solve for x over here? So we have log 81 is equal, so log 81 base x is equal to 2. Okay, how are you going to solve it? All right, I can say I have log 81 just based off of rule number 8. Log 81 over log x is basically equal to 2. And then I can take the log x to the other side. Okay, do some mathematics gymnastics. So we have 2 log x. By the way, if the base is not written, you can assume that it's 10. Okay, so what am I going to do here? What I'm going to do, I am going to take 2. Remember, this is 2 brought down. I can take it up there to be an exponent. So I have log 81 is equal to log x squared. Now the logs can cancel. Therefore, I have x squared is equal to 81. And if I root both sides, I know that x is equal to plus minus 9. Okay, cool. Now let's look at the second one. Ooh, I don't think I provided enough space for myself, but let's see. So I have log x squared plus 2x base 2 is equal to 3. So here, similar thing. I think that's why I said rule number 8 is actually quite important, because in most cases you're going to use that a lot. All right, so I'm going to say then log x squared plus 2x over log 2 is equal to 3. Okay, similar thing. I'm going to take log 2 to the other side. So I have log x squared plus 2x is equal to 3 log 2. And then that 3, I'm going to make it an exponent. So again, I have log x squared plus 2x is equal to log 2 to the power 3. Then the logs can cancel out. I have x squared plus 2x is equal to 8. 2 to the power 3 is 8. I'm going to take 8 to the other side. Then I have a quadratic function and life is good. So so 8, the factors of 8, I'm thinking 2 and 4. All right, because 2 times 4 gives me 8, and 4 minus 2 gives me plus 2. Okay, so now I have it that x is equal to 2, or x is equal to negative 4. I really didn't give myself some space. Okay, now let's go to 2a. I'm going to write it over here. So I have 5 to the power x is equal to 100. So the x is my unknown. All right. I mean, you could try and say, let me see, can I write 100 as base 5? No, this is just, 10 squared. So not really winning much there. So it's fine. But if I have an unknown as my exponent, what I can do, I can then say log base 10. No. Oh my gosh. The base is 5. My goodness. Log base 5 of 100 is actually equal to x. Okay. And can I do anything more? I'm just going to look at the answer here. I can't think of what the answer could be just by looking at it. So, yeah. Okay, I wouldn't have known. So basically x is 2,86. And there we are. And then b, I have 2 times 3 to the power x minus 3 is equal to 12. Okay, firstly, I'm going to take 2 to the other side, divide by 2 both sides. All right, so I have 3 to the power x minus 3 is equal to 6. All right, 12 divided by 2 is 6. And now, same story. x minus 3 is what I'm looking for. That's the exponent. And then log base 3, 6. Okay? And x then would be equal to log 6 base 3 plus 3. And what would that be equal to? Log 6 base 3 plus 3. And that's, yeah, there we go, 4,63. Alright guys, and basically that is the end of the lesson. I hope you enjoyed it and you learned a lot. By the way, like I said, rule number 8 is like the rule that you're going to use, as well as just knowing how to rewrite the log. This is the main thing, really. All the other ones, it's great to know. Whether you'll be examined or not, I don't know, but just know these rules just in case. And with that, I'm done. And please do not forget to like our videos as well as subscribe to our channel. I probably should have said that at the beginning. Bye.